All right, big day today, guys. Factoring and solving polynomial equations. Lots of stuff today, a lot of factoring, so get ready. 4 different types today. This is the first box up here. A general trinomial, and you're used to seeing this. We're going to do a method called slide, divide, slide, as I'll show you today, but you've seen that before. A perfect square trinomial is when you have a square, like the trinomial has the first term has a square root, the last term has a square root, and a lot of times you can factor it just by writing it x plus 4 squared. We have a difference of squares, which should be the easiest way we can factor. If you have two perfect squares that are subtracted, it must have a difference, must be subtracted. You can take the square root of the first one, the square root of the second one, do different signs, sum of difference, and you should be good. Common monomial factor, that's the most important thing to start with. If you look at the bottom of the screen, I put always look for GCF first. That's extremely important. Always look for that first. And sometimes that's all that you can do, and sometimes that's the complete factorization. Factoring polynomial is a definition. A factorable polynomial with integer coefficients is factored completely. You're going to see those words all day. If it is written as a product of unfactorable polynomials with integer coefficients. So when it's written like this or like this and you cannot factor it anymore, they're called factored completely. This one down here is not factored completely because you have a difference of squares inside that you can break down x plus 2x minus 2. So today's goal is to factor everything completely. All right, I'm just going to show you several examples here of different styles of factoring, and hopefully it's a lot of review for you, I'm hoping. All right, so first thing I'm going to do every time is look for a GCF. All these terms in the first one have an x, so I'm going to take out the x out of each term. And when I do that, that leaves me a trinomial, and that trinomial inside will factor some more. I'm looking for factors of 15 or negative 15 that would give me a positive 2. I would go with x plus 5 and an x minus 3. And that's factored completely. All right, so I took a couple of steps there. The second one, again, I'm looking for GCF first. So I can take out a 2 and a y cubed. That's what they have in common. If I take that out, that leaves a y squared from the first term and a 9 from the second term. And I'm looking at that parentheses, and that's the difference of squares. So I'm going to keep on factoring. So I'll leave my 2y cubed. Y squared minus 9 is the difference of squares, which you can write y plus 3. And y minus 3. All right, again, hopefully you've seen a lot of this before, and it's not a humongous deal. Let's try this last one. Again, GCF, let's take out a 4a squared. That's what they all have in common. If I take out a 4a squared, in the first term it leaves an a squared, in the second term it leaves a 4a, and in the third term it leaves a 4, just a 4, because I take out the a squared. Now, what I have left in that parentheses is a perfect square trinomial, which is what we saw in the first slide. You could do this. You could do a minus 2, because if you multiply negative 2 and negative 2, you get the 4, and if you add them, you get the 4a. Better off to write it like this, though, to go and write a minus 2 squared. You could have done that from the very first, from here to here, you could have written like that also, and not taking that middle step. So I got a couple more. A new one for you probably is a special factoring is a cube, factoring cubes. I have a great gesture for you that will help you learn this really easily. If you have a sum of cubes, basically you take the cube root of each number, and then you take the first number and you square it. You multiply those together and you change the sign, and then you square the b. And that's really all you do. And here's an example over here with the 8x cubed plus 27. I'm going to show you one in a second. It also works with differences. If there's a subtraction sign, the only difference is the sign's a little bit different. You still take the cube root of each number that goes there. Then you square the first one, you multiply together, change the sign, square the second one. That's what the gesture is going to kind of tell you. Let me show you a real live one here. All right, so let's look at this first one. It says x cubed plus 64. And if you're not sure if 64 has a cube root, you can use your calculator and punch in the cube root of 64 and make sure it has one, and it does, and it is 4. So I'm going to make a small parentheses and a large parentheses. In the small one, I'm going to go the cube root of each number. In the second one, you're going to square the first one, you're going to multiply them together and change the sign, and you're going to square the second one. And I'm going to give you that again tomorrow as a gesture. Now, one thing I promise you when you do cubes, once you get your second big parentheses right there, it's not going to factor anymore. It is factored completely already. You may need to look at this one, make sure it won't break down, but your second one will not. Okay, the second one, don't forget we always look for GCF first. They're both even, so I can take out a 2. I can take out an a squared. That leaves me with an a cubed for the first one and a 125 for the second one. Use your calculator, see if they have cube roots, and you won't believe it, but they do. The cube root of 8a cubed is 2a. The cube root of 125 is 5. So there's my first parentheses. My second one, you square the first one. You multiply the two numbers together, and you change the sign. So I'm going to make that plus 10a. Then you square the second number, which is 25. We're out of room right there a little bit, but hopefully, let me write that second parentheses one more time. Let's just try to squeeze that in there. Again, square the first number, 4a squared. Multiply them together, which is negative 10a, but you change the sign, positive 10a. Then you square the 5, make it 25. Your last number will always be positive because you're squaring it. And that second parentheses, as I said a minute ago, that will never factor more. That is factored completely already. Okay, one more style of factoring, factor by grouping. When you factor by grouping, you're going to group the first two terms, or find terms that you have things in common. Usually going to set it up for you pretty nice. So I'm going to take the GCF out of the first two, which is x squared. That will leave me with an x minus 3. The second parentheses, I'm going to take out a negative 16 because the 16 is negative, and this is what happens to my signs, which is what I wanted to happen. You need to get to the point where you get the same thing in both parentheses right here. You get an x minus 3 in both parentheses. The x minus 3 then becomes your new GCF. So I have x minus 3 and an x squared minus 16. And I would be done right there, except that x squared minus 16 is not factored completely. That's a difference of squares. I can do x plus 4, x minus 4. Let me back up real quick 1 second. When I got to this step right here, they both had x minus 3, so I pulled the x minus 3 out as if it was a GCF. And the reason I got the x squared minus 16 here is because if I take out an x minus 3, on that term it left me the x squared. On this term it left me the minus 16. So that's where that second parentheses came from. Factor by grouping. You should have done that style before. All right, these are just general ones. Most of your homework is just going to say this right here. Just going to say factor completely. You got to figure out what type of problem it is and just go with it. This first one, both numbers have square roots and there's a minus sign, so that's a difference of squares. So I'm going to take the square root of the first term, which should be 4x squared, the square root of the second term, which is 9, and I'm going to do 4x squared plus 9 and 4x squared minus 9. And you're like, yes, I got it, but then you got to look closer. This right here is another difference of squares, so you cannot factor a sum of squares, so 4x squared plus 9 stays there, but the 4x squared minus 9 you can break down to 2x plus 3 and 2x minus 3. All right, so that's factored completely. You just got to keep going so you cannot factor anymore. All right, the second one, move that over a little bit. The second one has a GCF. They're all even, so take out the 2. Take out the 2. Also, they'll have p, at least p squared, so I'm taking out the p squared. That leaves p to the 6th, 10p cubed, and 6. Now, one thing we haven't talked about yet is that's quadratic form. My parentheses, at first you look at like, I can't factor a p to the 6th, but you really can, because anytime the middle exponent is half as big as the first one, or you can look at it this way, the first one's twice as big as the middle one, you can factor it like you do a quadratic. So I'm going to put a p cubed and p cubed, and I'm trying to think of factors of 6 that give me 10, and you know what? In this case, none do. Factors of 6 are, oh, sorry, I see them on mistake now. That should have been a 5 right there. That's completely my fault because I took a 2 out of the 10, forgot to change it to a 5. You know what? If you make a mistake, you just fix it and you keep on going and learn from it. So that's what I just did. So I'm looking for factors of 6 that have to be 5. That's much easier. That'd be plus 3 and a plus 2. That's factored completely. Now, one thing you got to look for, make sure those are both p cubes. So I'm kind of thinking, could I factor a cube? But you can't because 3 doesn't have a cube root and 2 doesn't have a cube root. Okay, one more slide. Thanks for hanging in here today. That was, it's a lot of stuff. I know it's a little bit longer video than usual. So this one says solve. And we could say we're going to solve by factoring. So I'm going to take out the GCF first, which is 4x. That's going to leave me an x to the 4th minus 10x squared plus 9 when I take that out. So now I'm looking to factor my parentheses, what's in here. So that's a quadratic form again, so I can do x squared and x squared. I'm trying to think of factors of positive 9 that give me negative 10, and then be minus 9 and minus 1. Now, I have difference of squares. This is crazy. The first parentheses, I can do x plus 3, x minus 3, because it's a difference of squares. The second one, I can go x plus 1, x minus 1, difference of squares. So once you get it completely factored, you can tell what your answer is or what your solution is. Your answers are whatever makes each parenthesis 0. So this first one, would be 1. The second one, I'm going backwards, -1. This one, +3. This one, -3. And finally, this out here, what would you plug in for x to make 4x become 0? And the answer is you just plug 0 in. So 5 answers right there, which shouldn't be surprising because it was x to the 5th power. We'll talk about that later. But wow, guys, quite a video. Sorry for the length, but gives you something to look at, a lot of examples. We'll work on these a lot tomorrow in class, and I'll see you then.